Okay, so I said I was going to do a video on dot product, so I forgot, so I remembered, so here we go. So let's say we're doing dot product with R cross F, not dot product, cross product, good grief. I'm doing R cross F, so I need to make up an R and an F. So let's say R in unit vector notation was 0, comma, 3, comma, 0, I don't know. And this is your I, your J, and your K. And then F can be, let's say, 2I, 1.7J, and 0K. Just make that up. So if we're doing cross product with matrices, what you should do is this will end up doing a 3 by 3 matrix. So you do, so R cross F, we're going to make a matrix. So we got I, J, K on the first row. So then you just write the R, so this would be 0, 3, 0. So you're just writing the coefficients. Obviously, if there's nothing there, you probably wouldn't have 0, but yeah. So then we got 2, 1.7, and 0. So to do a determinant of a matrix, you essentially, well, I'll just go through the steps here. So the easiest thing to do is think about blocking out the things that you aren't using. So you can mark them out, but then I'm going to want to change them. So here, I'm going to try to lay this down like this. So I'm blocking out the top row, like I'm blocking out I. I'm trying to find I, so that's what I'm blocking out. So this will be I. So I go I equals, I don't know if I can see that on the video. So I would just be, let's do it like this. So I would be these things. So I'm going to do this and then this. Okay. So do 3 times 0 minus 1.7 times 0. And that's my I. Now I get J, so you can just say plus J, but you're not really adding them together. So J, you would block out the J row, which would also block out your tops. Now this is going to be a little weird, so let me redraw this. I, J, K, 0, 3, 0, 7, and 0. So when you block out the J, you essentially are going across the diagonal here. So you can kind of, some advice they give you is to like redraw like the I over here, 0 and 2, so it kind of makes sense. But you're doing the same thing. You're going to multiply this, multiply that, and subtract the 2. So J would be 0 times 2 minus 0 times 0. And then for K, you're going to do the same thing. Block this out, block that out. So K, let me redraw it, I, J, K, 0, 3, 0, 1.7, 0. So I mean, you can do it on the same one, but it's hard to see, so I'm just going to redraw it down here. So then K ends up being 0 times 1.7, 7 minus 3 times 2. So then you calculate each one. So this is 0, and this is 0, and this is 0. I put a lot of zeros in here. So you get 0I, the torque, equals 0I, comma, 0J, and then negative 3.2 K. Okay, or in easier polymers, the torque is just going to be negative 3.2 in your positive K direction, whatever that is. So, okay, that's how you do it on paper. It takes a while, and you can make mistakes. Hopefully I haven't made any mistakes here. But you can also do it on calculator. So I pulled out this TI-84. So to do this on a TI-83/84, you have to do matrix. So here we see the matrix here above the x to the negative 1. So you may follow along if you're trying to learn how to do this. So hit second matrix. And so it doesn't matter which one I use. I'm just going to use the first one. But I have to type this matrix in here. So the matrix is based on this information right here. So for me to do this, I need to go over to edit, and I'm going to edit, and just the first one. So matrix A, so I know it's going to be a 3 by 3 matrix. So I say 3, enter, 3, enter. Now I can enter my information. So for the I, J, K, what you want to enter in here is 1. So 1, 1, 1. You can't put 0 because it will give you nothing. So just put 1 so it doesn't change our values. So then we do the second one, which is 0, or R, 3 and 0. And then we do 2, 1.7, and 0. Okay. So that's it. We're done. So we hit second quit to get out of the matrix editor. But now I want to find the determinant of the matrix. So I want to say second matrix, right? X to the negative 1. And I see, you can see now it has something stored in it. It's got 3 by 3. So I'm going to go over to math, and you'll see determinant on this calculator is the first one. So hit determinant. Determinant of what? Well, hit second matrix again. Determinant of matrix A. Gives you negative 0.6. Oh my gosh. 3.2 is 6. 3 times 2 is 6. Oh my gosh. So yes, this should be negative 6. Well, that is the answer I had. I just forgot to multiply. Yeah, so either way, it should give you negative 6 in the k direction. Now, if this had multiple terms, it would list like the first one, comma, second one, comma, third one. It would know I, J, K. But yeah, so it would list all 3 if it had something. But in this case, that's just what it gives you. And go back and prove that real quick. Let me make something that doesn't cancel. So let's put, I don't know, an 8 over here. Okay, so that shouldn't cancel now. Maybe it should cancel. Whatever, I'm not going to go through all that again. Okay, so hopefully that gives you a quick fix on that. So, go ahead and stop that.